Hello there, I'm Skylar Stockham, and today's tech update is about EMG robotics control. So, EMG stands for the medical practice known as electromyography. It's normally used in medical practice to measure heartbeat, to measure muscle activity, and even to measure brain activity. And although it's not a very entertaining sounding thing, I encourage you to pay attention because it does have some very seriously cool implications. So my work personally involves something like this. We take amputees and we hook them up to a system that lets them control a robotic arm with their minds, essentially. This black sensors on this man's arm are actually EMG receptors, and they allow him to control the arm through nerve impulses. Now, I work at the lab up at the U Neuroscience Center, and this project was funded by the government. I think it was the Department of Defense, and they got something along the lines of $120 million to build this man this arm. We don't have that sort of money or tech, but we have something similar. So in our lab, we hook our amputees up to something like this. The inside is lined with electrodes, and they'll make the movements that they feel are normal to make with their hand. And those nerve impulses are the same even though they don't actually have the hand. So we connect this device here to this device here. And by doing that, they can control this robotic hand essentially with their thoughts because they aren't really moving any muscles. So because we have a finite supply of amputees and no one really wants to make more, we have to devise ways to improve our technology without cutting arms off. And this is where I come in. What you see right here is my project. It's the 96 electrode receptor. And what it's going to do is triple the accuracy and precision of the current arm electrode sensors we have in the lab. So the process of connecting these electrodes to the computer is actually fairly simple. We take these 32-pin inputs, we cut them in half, and we solder them directly onto the electrode. The computer takes care of the rest of it because all it really is an electrical impulse. Once the device is finished, we'll instruct the patient or the researcher to make specific hand movements, like clenching their fist or pointing a finger or making a thumbs up. These hand movements will correspond to different muscles, which in turn make different electric impulses. And that's where this receptor comes in. The different muscles will all have their own electrical output, and those will be caught up by our electrodes. Now, another slightly more intrusive means of collecting electrical data in nerve tissue and muscle tissue is the Utah slant array. Now, I'm sure as you can see, essentially what this is a bunch of needles that you'll inject into your arm or your brain even, and they will give you a much higher definition of the nerve impulses in especially nervous tissue, which is a lot smaller. This is an up close of that same chip-looking thing we saw in the penny. Essentially, this slanted array gives a full and comprehensive look at the nerve and allows for really accurate and precise readings of which nerves are firing. Here's a view of how this works. Essentially, if you have them all in a linear fashion, you don't capture the entire nerve. Even though the chip is tiny, nerves are even tinier. So if you put them in a slant like this, you can actually get a really comprehensive look at the nerve as a whole. Now, I know you're all thinking about how awesome this is, and I am totally with you. It's super cool to think that we can cut our arms off one day and be like Luke Skywalker and Anakin Skywalker. But this technology goes way beyond robotic hands. That's right, mind control. Now, normally in modern rhetoric, mind control is someone controlling your mind. And we'll get into that a little bit later. But mostly what we'll be talking about today is how you can use your mind to control your surroundings. Now, when we apply the principles of EMG to the brain, we call it EEG. And it's just as it is with the nerve tissue, it's a surface level reading. So you don't get to see all of the electrical activity in the deeper areas of the brain as you would with an MRI. But the technology is portable, so you can perform research on patients that you wouldn't be able to when you're laying down in an MRI. So your brain, like a computer, is just a system of ones and zeros. Either a nerve's firing or it's not. And if you have one nerve that fires, you're going to have another nerve that fires, which essentially means that you have inputs and outputs. So you can actually read the brain just like a computer. And thus, you can control things like you would with a computer with your brain. Now, this has some very serious implications. If we take the technology from earlier and apply it to the brain, we'll actually be able to not only know what people are thinking and how they're feeling, but we'll be able to control environments based on what they're thinking and how they're feeling. Let me explain. So just as we can map certain hand movements to electrical impulses in the forearm, we can do the same thing with the brain. So as you can see here, if you're angry, your amygdala fires. And if we're measuring EMG activity, we can figure out if you're angry just based on electrical signals. We can also figure out a lot of other stuff about where the brain's going. Hypothetically, if this technology is able to advance to the next step, which is a portable device which you could wear and which would measure your brain activity, you could have a computer that could administer drugs based on how your brain's working. For instance, if you're having a seizure, it could administer anti-seizure drugs. Or if you're having an extreme bout of anger, it could administer a depressant. This may be pushing the limits of our understanding of consciousness, but perhaps one day if you thought of a song in your head and you couldn't get it out or even put a name to it, your echo could not only monitor what you say every day, but what you think, and you could play the song that's stuck in your head. If that didn't make your skin tingle a little bit, you probably have some serious soul searching to do. This technology has numerous opportunities and some serious potential to really change the way that we humans interact with technology and even interact with each other. I hope you enjoyed my tech update for a topic that sounds about as interesting as the IRS. I think it's really fun to think about where this technology could go in the future and how it could impact our lives. Thank you.